Hello everybody, today we're going to be learning about half reactions. So what is a half reaction? A half reaction is a type of redox reaction where it's basically a method for balancing oxidation and reduction reactions in an aqueous solution. Let's start off by defining the terms of oxidation and reduction. So, oxidation and reduction are very different because oxidation is when it loses electrons and reduction is when it gains electrons. However, oxidation, even though it loses electrons, it makes the charge more positive, so it adds on to the charge. While reduction, even though it gains electrons, it becomes more negative, making the charge become less than what it initially was. So before we begin, let's lay out the steps. Step 1, we must understand the oxidation numbers and write out every single oxidation number on top of every single molecule. Here's an example so that we can practice. Cr, being an individual molecule, has a charge of 0. Pb has a charge of +2. Cr has the charge of +3, and then Pb there has the charge of 0, since it's an individual molecule. Ca has 0, Au already lists which is +1, Ca there is +2, and Au is 0. Oxidation numbers also have a lot of rules. So for example, the sum of the oxidation numbers equals the total charge of the molecule. The oxidation number for a neutral element that's not bonded to another type of atom is 0. And there are several others, such as the charge of hydrogen, the charge of alkaline metals. Now that we learned how to add the oxidation numbers to every single molecule, we can get to the real steps, which is writing out the half reactions for oxidation and for reduction. Here's an example to show how it works. Let's go back to the same example that we used to figure out the oxidation numbers. So Cr goes from 0 to +2, which means that it's oxidation. Pb goes from +2 to 0, which is more negative, which means it's reduction. Another crucial step is that when writing these half reactions, we must always write the reactants first and then write the arrow and the products, which are on the right side. Now let's begin by writing out the oxidation and the reduction reactions. We've already established that the oxidation is Cr, so let's write out Cr without a charge, arrow, and then Cr +3, which is what it becomes. Since it loses electrons, it gets a +3 charge. So to balance it out, let's add 3 electrons. Next, we can move on to the reduction reaction. The reduction reaction starts off with Pb +2. Then we can skip the arrow for a second and go back to it later. So then we draw the arrow and Pb, which is lead, with a charge of 0. Since Pb goes from +2 to 0, that means that it gained electrons and made the charge more negative, which is why we add 2 electrons to balance it out. However, 3 and 2 electrons are not even, so to even it out, to balance it out, we have to multiply the chromium by 2 and the lead by 3. After that is all balanced out, now we must complete it by multiplying, so we will end up with the oxidation with 2 chromium, arrow, 2 chromium with the +3 charge, plus 6 electrons, because 2 times 3 is 6. And for the reduction half reaction, we get lead, 3 lead with the +2 charge, plus 6 electrons with an arrow, and 3 lead. Since that part is all figured out, now we must plug in the numbers into the original equation and add a 2 next to the chromium, add a 3 next to the lead, add a 2 again next to the chromium, and a 3 next to the lead, which is basically just gathering the information that we already established by multiplying both of the half reactions and putting it in. And now on to our next example. Ca, which is calcium, goes from 0 to positive 2, becoming more positive, thus making it oxidation. Au goes from positive 1 to 0, becoming more negative, which makes it reduction. So to start off with oxidation and then going on to reduction, we begin with the reactant, which is Ca with no charge. Then we draw the arrow and go to the products, which is Ca plus 2 plus 2 electrons to balance it out. And onto the reduction, we get gold, which is Au, on the reactant side, which is plus 1. Then we leave the little space so that we can determine how many electrons will need to be added. Draw the arrow and draw Au, gold, with a 0 charge. Then we have determined that it is plus 1 electron to balance it out to make it Au plus 1 electron. However, the 1 and the 2 are not equal, so we must multiply the gold one by 2 to make it equal to the 2 electrons on the calcium side. So it will end up to be 2 gold plus 1 plus 2 electrons, arrow, 2 gold. And again, now that we have finished the half reactions and multiplying it to balance it out, let us add the numbers to the redox reaction. So we add the 2 next to the Au, and the calcium again doesn't need anything, and then we add another 2 next to the Au, and then done. Thank you all for watching. See you next time.